you're going to state your claim. The claim is given to us. The claim is in HO. Therefore, HA is a not equal. Remember, this one works different. There's no negative values. They go from 0 all the way up. So if you're going to share 0.05, remember to divide it in half. There's no inverse norm on this. There's table 6. Go to table 6. Make sure you look up table 6. Make sure you look up your degrees of freedom. And make sure you look up both of these, 0.025 and 0.975. The larger one goes on the right. The smaller one goes on the left. And you should say reject H0, fail to reject H0, reject H0. Make sure you use H0 because there's an HA there also. All right, so you're going to take your formula. I'm going to give you this formula to find your test statistic. Those are your critical values. They don't belong on your test statistic does not belong down there. Just your critical value does. Make your test statistic, find your answer, and see where does this fall. Like it falls in your fail to reject, HO. That's your decision. Yes.
Do I need to draw it in on my sketch?
Well, you don't have to, but I don't want to see them written down here in place of these guys. So some of you guys kept giving me your test statistic as your cutoff, and on the other ones kept making a negatives and positives. These are your critical values. So just like kind of draw me a little line, where does it fall? Show me where it falls. It falls in the fail to reject H0. Follow your chart. There is not enough evidence at a level of significance of 0.05, and all we know is what they gave us. To reject the claim that the variance is equal to 0.52. No words to this one, just whatever it is that they gave us. Everybody okay with that? Is there something that's not working? Critical value test? No? Everybody's good? This one does work differently, but you can kind of see the similarities. The pattern is the same. You have your claim. Your claim in this case is an HA. Find your HO. It's a left tail test. It follows your HA. You're looking at 0.01, but look up both of these, 0.99 and 0.01. It's the 99 that's going right here. This is your critical value. You want the lesser of the two. It's because area is to the right on your chi-square. So put the smaller of the two there. Do your test statistic. Everybody good? Okay, I'm going to get through these, but I want you to tell me to stop if you don't get it. This is important. Tomorrow you'll have a quiz and we'll wrap this up. So a school administrator says that the standard deviation, so therefore I should see this parameter, standard deviation, not P, not U, not blank, of test scores for the 8th grade is greater than, there's my math statement, 30 points. I took a sample of 18. They have a sample standard deviation of 30.6. And you want to know, is there enough information to support the school administrator's claim? There's his claim. And support means HA. Make sure it's an HA. Find your cutoff value for your 0.01. Test statistic. No p-vals on this. Just reject H0, fail to reject H0, region zones. I'm shocked. Tomorrow, you all better get hundreds on this quiz. 98. We'll take a 98, Jared. We'll take a 98. A travel agency estimates that the standard deviation of the room rates of 3-star hotels in Chicago is at least, how do I say at least? Greater than or equal to. That's the least it can be. Not less than or equal to. A lot of you guys make a mistake on that. It's at least $35. So you randomly sample 21 hotels. You find your sample standard deviation. You got a left-handed test because your HA is a less than. We're good with this? Everybody has the right cutoff. The right labels. And the last one, you have to put this in your L1. Remember, in your L1, you're looking for SX. Sample standard deviation, not population. Population comes from your claim. Your statement is made about a population. You test this with your sample. Degrees of freedom. Don't forget it's a two-tailed test. Divide the 0.05 in 2, 0.025, and 0.975. That's it? We're good. Okay. That's your course in a nutshell.